Hello and welcome back to my amateur radio general license course. Thanks for joining me on this beautiful day in the amateur radio neighborhood. You know, the state-of-the-art electronics has come a long way since the early days of amateur radio. In the beginning, enthusiasts made their own transmitters and receivers. A lot of them were called spark gap transmitters. But today, few people homebrew their own equipment anymore. But instead they elect to purchase their equipment. Most transceivers sport microprocessors, digital signal processors, speech processors, and components that are so small it's well beyond the abilities and the technical prowess of most of us to even assemble, much less to design. And while we are not expected to be able to build our own equipment anymore, we are expected to understand how they work fundamentally and what their capabilities are and how to operate it. So, are you ready to learn? Well, let's get started. This is the Amateur Radio General Class License Course, Lesson 4, Part 2. I'm your instructor, Gary Stevens, and my call sign is KE2GS. That is Kilo Echo 2 Golf Sierra. Today we're talking about the second part of subelement G4, the amateur radio practices. There are 5 exam questions that come from 5 groups of 67 questions in total. This covers the General Class License Pool 2019 to 2023. That was effective July 1st, 2019. Today we're going to dive back into operating procedures. We're going to talk about interference to consumer electronics, grounding, and digital signal processing. We're going to talk about speech processors, S-meters, sideband operation near the band edges, and HF mobile radio installation, and alternative energy sources of operation. Really exciting stuff. And now everything you ever wanted to know about interference to consumer electronics, grounding, and digital signal processing. Sometimes amplifiers can have a 60 cycle hum. That's just kind of noisy. And one of the ways that you can eliminate it is using a bypass or a decoupling filter or a capacitor. In this schematic, there's one on the input and one on the output. On the exam, you need to know that a bypass capacitor might be useful in reducing RF interference to an audio frequency device. If you or your neighbor is arc welding, you're probably going to hear interference on your radio frequencies. The reason is because arc welding is a poor electrical connection, and that's where you get the arc from. But for the exam, you need to know that arcing at a poor electrical connection can cause an interference covering a wide range of frequencies. Perhaps the greatest distortion of speech is when a politician talks and the media reports on it. For the exam, you need to know that distorted speech is heard from an audio device or a telephone if there's interference from a nearby single sideband phone transmitter. Because with Morse code, the CW transmitter is basically on and off. It's just an on and off switch. It's triggering the signal on and off. And that can sometimes cause clicking interference in other devices. So for the exam, you need to know that an on and off humming or clipping is an effect of an audio device when there's interference from a nearby CW transmitter. This is a picture of RF burn by touching a cabinet that wasn't properly grounded. For the exam, you need to know that if you receive an RF burn when touching your equipment while transmitting on an HF band, assuming the equipment is connected to a grounding rod, the problem might be that the ground wire has a high impedance at that frequency. So you want to make sure that your connections to your grounding system are good. Another reason that we need to have a good ground system on our rigs is because the high voltages can resonate because of a ground connection or a bad ground connection. So you need to know for the exam, high RF voltages on enclosures of station equipment is an effect caused by a resonant ground connection. So normal 60-40 solder, which is 60% tin and 40% lead, has a melting point of about 190 degrees centigrade. By contrast, a bolt of lightning has a temperature of about 53,540 degrees Fahrenheit. The solder doesn't have a chance. Ferrite choke can suppress all kinds of RF interference on an audio cable. I have one in my car that reduces the noise from my phone. For the exam, you need to know that placing a ferrite choke around a cable will reduce RF interference caused by common mode current on an audio cable. So we all hear about ground loops. And the best way to avoid it is to connect everything to a single point, a single strip of a metal which is then grounded into earth ground. So for the exam, you need to know that a ground loop can be avoided if you connect all ground conductors to a single point. Isn't that what I just said? Well, it doesn't happen often. We can get a report from someone that our station has a hum. It's an easy fix, just ground everything into a single point, like the previous slide suggested. For the exam, you need to know that when you receive a report of hum on your station's transmitted signal, it could be a symptom of a ground loop somewhere on your station. And connect it to a single ground, it'll go away. This question, let's just take it at face value and go for the answer. Bonding all equipment enclosures together is a technique that helps to minimize RF hotspots in an amateur station. The ARRL has all kinds of books on grounding, and there's all kinds of theories and controversies, and it's just too much to go into in this slide. Digital signal processors can be both software defined, and they can also be in silicon. For the exam, you need to know that an advantage of a receiver digital signal processor intermediate frequency filter as compared to an analog filter is the wide range of filter bandwidths and the shapes that can be created. When it comes to metal cabinets or metal enclosures of any kind, just ground them all together to your station ground. That will keep you out of trouble with hazardous voltages, and old equipment has higher voltages than newer equipment. So for the exam, you need to know that metal enclosure of every item of the station equipment should be grounded because it ensures that hazardous voltages cannot appear on the chassis. And that brings us to the next section where we're going to be talking about speech processors, S meters, and sideband operation near the band edges. The purpose of a speech processor is to increase the intelligibility of transmitted phone signals during poor conditions. What's interesting is the speech processors, as I mentioned before, come in all different forms. They can either come on silicon or they can be software defined. I personally kind of favor the software defined ones. They seem to be more versatile. And this unicorn just indicates the magical properties of a speech processor. We could spend days talking about speech processors. It could be a course by itself. For the exam, you need to know that a speech processor affects the transmitted signal sideband phone signals because it increases the average power magically. While this is magic when it works well. Speech processors, when they don't work, can be a kind of nightmarish. You need to know for the exam that distorted speech, splatter, and excessive background noise can be picked up through the result of an incorrectly adjusted speech processor filter. So we need to know what a S meter is, and basically all an S meter is a meter that shows us our signal level or signal power level. For the exam, you need to know that an S meter measures received signal strength. As you recall, in our earlier discussions about decibels, they're logarithmic. So this question deals with the logarithmic nature of the power meter. Assuming that a properly calibrated S meter, a signal that reads 20 dB over at S9 compared to one that reads S9 on the receiver is 100 times more powerful. And of course, we all know that an S meter is found in a receiver and not the transmitter, because an S meter is our received signal level, not our transmitted level. When we increase our transmitter, it does change the S meter that the receiving end is looking at. For the exam, we need to know that the power output level of a transmitter can be raised by approximately 4 times in order to change the S meter reading on the distant receiver from an S8 to an S9. So we understand that our carrier frequency is set in the center when we're dealing with upper and lower sidebands. So when we're talking about a lower sideband, the 3K signal would be below our carrier frequency or center frequency, and the upper sideband would be above it. For the exam, we need to know that when a displayed carrier frequency is set to 7.178 megahertz, the frequency range of 7.175 to 7.178 megahertz is occupied by the 3 kilohertz lower sideband signal. Likewise, the same is true for the upper sideband, only going in the other direction. So for the exam, we need to know that when the displayed carrier frequency is set to 14.347 megahertz, the frequency range of 14.347 to 14.350 megahertz is occupied by the 3 kilohertz upper sideband signal. And because the lower portion of the band in this case is 7.175, the lower segment for a general, we need to stay at least 3 kilohertz above that. So for the exam, you need to know that at least 3 kilohertz above the edge of the segment is how far above the lower edge of the phone segment we should display our carrier frequency when using a 3K WITS LSB. And likewise, for the upper sideband, at least 3 kilohertz below the edge of the sideband is how far to the upper edge of the sideband or the phone segment your display carrier frequency should be when using 3 kilohertz wide upper sideband. We are knocking this thing out of the park. So we're up to HF mobile radio installations and alternative energy source operations. Good stuff. So if you're really observant, you might see a mobile rig with a funny looking thing on their antenna that looks sort of like this. It's called a capacitance hat. And for the exam, we need to know that the purpose of a capacitance hat on a mobile antenna is to electrically lengthen a physically short antenna. So we can get more bang for the buck. And likewise, you may see a little ball or a little device on the end of an antenna that looks similar to the picture here. And it's called a corona ball. And the purpose of a corona ball on an HF mobile antenna is to reduce the voltage or RF voltage discharge from the tip of the antenna when you're transmitting. You don't want sparks flying off of that thing while you're going down the road. And when we're connecting our expensive radios to our automobiles, we don't want them to fry. So one of the things that we do is we used fused connector. Um, so for the exam, you need to know a direct fused power connector uh, that goes directly to the battery using a heavy gauge wire is best for a 100-watt HF mobile installation. So many of you will get a mobile rig, and the first thing you'll do is want to get one of these and uh, try to connect it through your accessory. Do not do it. Um, it's a bad idea. For the exam, you need to know that it's best not to draw DC power for a 100-watt HF transceiver through the vehicle's auxiliary power socket because the socket's wiring is inadequate and the current drawn uh, by the receiver will just be too much. So as we're looking at the limitations for HF radio or mobile installation, there's limitations. One of the most interesting things is we're more severely limited by an antenna that's electrically short than by any other means. For the exam, you need to know that the efficiency of an electrically short antenna limits an HF mobile installation more than wire gauge, picket fencing, or FCC rules. And one of these disadvantages is the bandwidth could be limited. So for the exam, you need to know that one disadvantage of using a shortened mobile antenna as opposed to a full-sized antenna when operating is that the bandwidth may be very limited. DC motors, often have brushes, and those brushes cause sparks when they rotate. For the exam, you need to know that a battery charging system, a fuel delivery system, and a vehicle-controlled computer may cause receiver interference at a radio installation when it's installed in a vehicle. I received a phone call about converting your house to solar. They may have talked to you about photovoltaic conversion. There's an interesting diagram. I'm not going to go into it, but for the exam, you just know that photovoltaic conversion is the name of a process which sunlight is directly converted into or changed into electricity. For the exam, you need to know that 0.5 volts DC is the approximate open circuit voltage from a fully illuminated silicon photovoltaic cell. If you look in a catalog, you might find some that are actually higher, but for the exam, 5 volts is, or half a volt is the approximate open circuit voltage. You need a diode when you're charging from your solar cells. Actually, the best bet is a charge controller, but you can use a diode. For the exam, you need to know the reason that a series diode is connected between a solar panel and a storage battery that is being charged by that panel is that the diode prevents a self-discharge of the battery through the panel during times of low or no illumination. In other words, the diode only allows the voltage to flow in one direction, and you want it to flow to the battery and not from the battery. If you live in an area where it's windy most of the year, you might be tempted to get a wind turbine. They're relatively inexpensive these days. For the exam, you need to know that a disadvantage when using the wind as a primary source of power for an emergency station is that a large energy storage system is needed to supply power when the wind is not blowing. Actually, that's somewhat true for solar power as well. The sun does not shine at night, so there you have it. And that concludes this lesson. So that's the end of Lesson 4, Part 2. Next up will be Lesson 5. Well, that wraps it up for this lesson. I hope that you enjoyed it. If you have any questions or comments, please ask them below. Please like and subscribe to this channel if you feel so inclined. Also, please excuse any misspellings or any mistakes that I made in producing this. I'm trying to offer this as a free class, free lesson, and without any advertisement, and I'm doing it as a public service. I'm doing it to help you as the viewer and the student learn the amateur radio and to pass the FCC license. And while I strive to do my best, I don't have the best studio in the world, and I don't have deep pockets to make it perfect. I don't even have the time to make it perfect. I barely have the time to make what I make. So I hope you guys can appreciate that fact. But until next time, never stop learning.